Okie doke. We are going to do more trig proofs today. And these are the tools that we already have from doing some proofs in, I think it was 5.2. Hello, Miss Kelsey. The first one, write in terms of sine and cosine, and you already have this list. You don't have to copy it again. I just wanted to run through these three tools you already have. Write in terms of sine and cosine, remember, is my if you can't think of anything else to do tool, but see if you can avoid it. That's not always the easiest thing to do. It's just when you can't think of anything else, then you can write in terms of sine and cosine. Second tool, you can use one of the three Pythagorean identities and make sure that you understand, for example, just because sine squared plus cosine squared equals 1 doesn't mean sine plus cosine equals 1. All right? You can't just take plain old sine and put 1 minus cosine in its place. You have to solve for sine or solve for cosine, and that would involve taking the square root of both sides. Third tool was split or combine rational expressions. When you see fractions, you almost always either get a common denominator and add them, or you have a binomial over a monomial. You can separate it into different fractions and see what happens. We can go ahead and start at the beginning of 6.1. We will pick up a couple more tools along the way, but I think what we have now is enough to do number 2. Show that sine x plus cosine x cotangent x equals cosecant x. I'm going to try my best to always remember to write the show that statement. Huh? No. Nah, I've got bigger fish to fry. Usually start with the left-hand side. The only time I don't start with the left-hand side is if something just leaps out at me from the right-hand side. It is a good idea to always start with the more complicated looking side because it's easier to simplify than it is to expand. So definitely I'd start with the left side there. But remember, you're going to start with one side and work on it until it becomes the other side. And no more scribbling all over the place, right, Luke? You're going to get it. You're going to get this logic thing if it kills you. Now, this is the only time all semester that I say, in order to get credit for it, you have to do it my way. But that's the way proofs are. You know, they're not just can you simplify or can you solve. It's can you logically, step by step, show that this expression equals that one. Now, in 5.2, I don't know if we had any proofs that were more than maybe 3 or 4 steps. 6.1, they get just a little bit harder. Still not bad. You see anything that you could do to this left-hand side? And that's kind of my if nothing else occurs to me method, but nothing else does occur to me there. If I have squares and ones, I look at my Pythagorean identities, but I don't, so I really can't think of anything to do but write cotangent x as cosine x over sine x. Wait, this wasn't the problem on the test, was it? That all of a sudden looks very familiar all of a sudden. Because this is cosine squared over sine. To get a common denominator, all you'd have to do is multiply by sine x over sine x. Don't skip any steps. This is sine square x over sine x plus cosine square x over sine x. You have two fractions you can combine, and when you do, your numerator is a Pythagorean identity. Sine square plus cosine square is 1, and 1 over sine x is cosecant x. Is that exactly how it was written on the test? Gosh, yeah, that's number 15 on the test. All right, so some of these problems you could have done in 5.2. That wasn't really any harder than any of the problems that we did in 5.2. Some of them get a little more involved. For example, number 4, we didn't have that in anything quite this ugly in 5.2. No, not at all. But you know what you don't want to do is just lose your argument completely. I know that when I'm reading trig out loud, sometimes I don't say the argument. I'll just say tangent plus 2 cosine cosecant. But without the argument, the trig function means nothing. It's like writing square root with nothing under it. So just make sure you have an argument. If you change it to x, that's okay. All right, eeny, miny, miny, mo, nothing leads me to believe one of those sides would be easier to work with than the other. So if that's the case, I just usually start with the left-hand side. And work on it till it becomes the right-hand side. And you're really going to have to get comfortable in 6.1 with just trying something, and if it doesn't work, either erase, or if you write in ink like I do, mark it out and start over. All right, any ideas? No Pythagorean identities jump out at me. I don't have a rational expression. The only thing I can think of is write in terms of sine and cosine, and maybe some stuff will cancel. So that's tangent t is sine t over cosine t. And cosecant t is 1 over sine t. So I can write that second term as just 2 cosine t over sine t. Then what? Can't think of anything else. No, I can't think of anything else to do. I can't see the clear path that would lead me down, but I just can't think of anything else to try. So I'm going to get a common denominator, multiply the first fraction by sine over sine. That would give me sine squared t over cosine t sine t. And I have to multiply the second fraction by cosine over cosine. That would give me 2 cosine squared t over cosine t sine t. At this point, I really wish that 2 wasn't there, because if it was, I would have sine, or if it was not, I'd have sine square plus cosine square, and that's 1. I don't think I could ever get it to be equal to the right-hand side, but it would be simpler to clean up. What else can we even try here? Actually, I didn't write it as a single fraction yet. I just got a common denominator. If I cancel right here, I would be going back to the line above. So let me go ahead and combine those numerators before I accidentally cancel out my common denominator. Splitting into two fractions would be going right back where I came from. I don't want to do that. What else can you think of? That never occurred to me. It's absolutely legal. I'm going to try it just because I never have, but I'm going to try it on scratch paper in case it doesn't work. I like that idea. The 2 cosine square t, write as cosine square plus cosine square. That's what you're saying, right? Okay. That's kind of cool. What did you say to do after that, Raven? Okay. I like it. So far, so good. Then what? Okay. Do you already know that this is going to work, Raven, or are you just thinking it may work? Can you see all the way to the end now? I know. I have to look back and see where I'm trying to go. I'm trying to get secant, cosecant plus cotangent. I can see it now. Split this up into 2 fractions. Oh, okay. Okay. Yeah. Yep. I like it. That's different than I did, and I really like it. This 1 over cosine sine can be taken apart into 1 over cosine times 1 over sine. You can skip baby steps as long as I can follow your logic all the way through. I don't want to rewrite the whole thing just to split the 1 over cosine times 1 over sine. I'm going to go ahead and say that that is secant t cosecant t. And in the second fraction, the cosine in the denominator cancels one of the cosines in the numerator and leaves you just cosine t over sine t. And that's the definition of cotangent. And that's what we wanted. Which makes me wish, Raven, that I hadn't written it on scratch paper. I should have just trusted you. I'll show you. On your 2 proofs on the test, if I wrote cool That's different than I did. That's really what I meant. I mean, some of you took approaches that were a tiny bit different than mine. And then I remember one person taking an approach that was way different than mine, but you still got there. You may have gotten there faster. I may have gotten there faster. It's not a race. I think it's neat when you think of a different way to do it than the exact same way I did. What did I do on this one? I ended up marking out. Oh, I see. Excuse me. I immediately, when I saw sine squared and cosine square, I did think of a Pythagorean identity. I put 1 minus cosine square in place of the sine square. So the 1 minus cosine square plus 2 cosine squared combined to just give me cosine square. And from there, I split it up and did the same thing you did. So the only step that's different is this one. And they look about the same level of difficulty. All right. Number 6. Show that tangent plus cotangent times cosine plus sine equals cosecant plus secant. Remember, one of the reasons for doing these trig proofs, not only is it just good mental exercise that makes your brain stronger, but in calculus, sometimes you can get very different looking answers, and you're trying to check your answers in the back of the book because it doesn't do you any good to spend an hour on homework and not know if you got the answers right or not. So you do all the calculus and you come up with this answer, and you look in the back of the book and they have a completely different looking answer. You just real quickly need to be able to see if your answer simplifies to what they have, or can you show that the two are equivalent. All right, the left-hand side definitely looks more complicated. I'm going to work on it until it becomes cosecant plus secant. Miss Kaylee, what can you think of to try? Whether it's the best thing or not, what can you think of? All right. Actually, it makes sense to do two things here, and it doesn't matter in what order you do them. Either you can rewrite in terms of sine and cosine and then multiply, or you can multiply and then write in terms of sine and cosine, but I think you'll have to write it eventually in terms of sine and cosine to see what cancels. I'm like you, I did my multiplication first. Absolutely doesn't matter though. Let's rewrite in terms of sine and cosine and see what happens. Is that what you got when you simplified, Kaylee? You have an idea of what to do next? Anything we could try? You know, the only thing that scares me about that is if we multiplied by the first fraction by sine over sine and the second by cosine over cosine, we'd have a sine cubed and a cosine cubed. I'd like to avoid that if possible. There may not be a way to avoid that, but I'm going to try to think of something else because I don't have a Pythagorean identity involving cubes. Yeah, I can factor the sum of two cubes, but you know, when I do, I get a binomial times a trinomial, and the binomial would just be sine plus cosine. I don't have a Pythagorean identity for that. The trinomial would be a trinomial. That's what I was thinking. Maybe either write sine squared as 1 minus cosine squared or cosine squared as 1 minus sine squared. I don't see where that'll lead me, but I can't really think of anything else to do other than get a common denominator, and my gut says stay away from the cubes. So let's see. Look at what we're trying to end up with in trying to determine whether to change sine squared to 1 minus cosine squared or cosine squared to 1 minus sine squared. Look at what we want to end up with. We have cosecant and secant. That means our answer, probably the step before we're through, is going to have both a sine and a cosine in it. So I don't think it matters which one of these we change. Let's just... Which did you suggest, Tori? All right. Let me catch up with you. Really? Change them both? Oh, okay. Um, okay. Okay. I was just going to change one of them and see what I could do next, but okay. Do both of those at once. All right. All right. Let everybody catch up. Split that second term into two fractions and the third term into two fractions. Cool. Mm-hmm. Nice. These two? Oh, that is probably less likely to occur to me, but absolutely fine. You could write sine u as sine square over sine, and then when you added these two fractions, you would just have 1 over sine. That's cool. And do the same thing for this, right? Cosine as cosine square over cosine and add those two fractions. That's neat. That's neat also. Remember in a I don't know if engineers have to take a class that's just pure proofs or not. I know that if you're a math major, you do have to take a class that's pure proofs. You don't get to skip any steps at all, and out beside every one of your steps, you have to say what property of real numbers or what trigonometry or state your reasoning, and you can't end until this looks exactly like where you should go. I'd rewrite that with one more step and say cosecant u plus secant u by the commutative property of addition, which just says it doesn't matter in what order you write the terms when you're adding. But y'all don't have to do that. What did I do? I did that completely different. It looks like it. It looks like it. Oh, look at this. Instead of writing in terms of sine and cosine and immediately going to the multiplication, first outer inner last, instead of doing that, once I wrote in terms of sine and cosine, I went ahead, and I don't know what made me think to do this, but I went ahead and got a common denominator and added these so that I had sine square plus cosine square in the numerator, and I replaced that with 1, and then the thing I was distributing was much easier. I didn't have to full, I just had to distribute 1 over sine cosine. But it's all right. Miss Klein, you kind of like these, don't you? You're thinking about being a pure mathematician. Who needs a job? Let's just do proofs for a living. All right. Number 8. I like that in trig, sometimes you have identities that just wouldn't work for real numbers. For example, if you had just 5 squared minus 2 squared, that certainly wouldn't be the same thing as 5 squared times 2 squared. It doesn't work with numbers, but it works with trig functions. Any, miny, miny, mo. I'd probably rather start with the left-hand side and maybe end up getting a common denominator or something, trying to simplify it to the right-hand side. Miss Sharisa, give me anything you'd like to try and we'll try to make it work. Anything that occurs to you. You're thinking, you know what? Part of it is just willingness to be wrong. And that's hard. I said to somebody yesterday as we were leaving, I don't remember who, based on 20-something years of teaching, I've lost count, 22, 23, I find that women have a harder time just trying something and it's okay if I'm wrong than guys. Apparently that's how guys live. We'll just try, and if it's wrong, we'll just hit it with the hammer and go on. You're used to being wrong. No, I don't know what it is, and certainly that's a generalization, not that doesn't apply to everyone. But for me personally, it was very difficult to write down something not knowing whether or not it was right. It's like I committed to a path that I wasn't sure was the straight and narrow, and that was hard for me for a while. All right, does anybody have any idea at all of something we could try? We don't have one with tangent and sine in it. Might end up with a cube in it if I do that, but I really can't think of anything else to try. All right, so sometimes you just have to write down something. No, I'm not going to have a cube. That's good. I try to avoid the cubes. To get a common denominator, I'd have to multiply the second fraction by cosine squared over cosine squared. Mm-hmm. What did you say, Nick? Yeah, that's the key sometimes. Factoring is a good thing. one of the most important skills in algebra and trig and calculus. That's the most obvious thing to try. I don't know where it'll take me, but let's factor out a sine square and see what happens. You see it, Chris? What do you see? You mean squared? This is sine square? Okay, let's write it that way. I think I get what you're saying. Sine square alpha over cosine square alpha for one of the factors, and then sine square alpha. Oh, wait. Something's not good about that. Oh, let's play like I didn't do that. You know what I almost did? What was bugging me for a minute? I was thinking that when I split that apart, cosine square was going to be in both denominators, but this is multiplication. This is also why you need to check and make sure every line's equivalent to the line above it. If I had written down sine square alpha over cosine square alpha and then sine square alpha over cosine square alpha, I would have immediately checked that and I would have seen that that would give me a cosine fourth in the denominator. Oh, that's wrong, and I would have erased it. So I think this is one time that it's good to be OCD. Make sure every line is equivalent to the line above it. That's actually what we're going for, tangent squared alpha, sine square alpha. What is it, Miss? Sorry. Let's see. I'd like to get to 14 because that's where we get a new tool. That would be 3 more problems. We might get 3 more problems in 15 minutes. Um, 10. Don't worry about the 3 that's with the beta. As long as all of the arguments of all the trig functions are the same, you could just call it ugly. That's 1 plus cosecant ugly over secant ugly minus cotangent ugly equals cosine ugly. And it definitely looks like I should start with the left-hand side. Let me think for a second. Hold on a second. Write it down, Tori. It seems like splitting up that fraction might be a good thing to do, or you could write cosecant and secant in terms of sine and cosine and then clean up the complex fraction. That'd be okay too. Splitting it up seems like something to try. Oh my gosh. Look at this. This is way faster than I have on my paper. If I go ahead and write that cotangent as cosine over sine, I'm only one step from being there. That cosecant over secant is 1 over sine divided by 1 over cosine. You could write it that way, or you could go ahead and say 1 over cosine divided by 1, I'm sorry, I said that wrong. 1 over sine divided by 1 over cosine is cosine over sine. Cool. Now really, when you're doing a proof, you shouldn't have any little scribbling out to the side, but the middle step that you could have put in if you needed to, and I probably should have, oh, not that, this. That cosecant is 1 over sine, and that's divided by 1 over cosine. And then the way you divide by a fraction is to multiply by the reciprocal. When you take the reciprocal of that 1 over cosine, you get this. All right, 2 more. Number 12. Luke, give me an idea of anything at all you think we could try. Well, I just couldn't hear you. Trying to think of where you're saying 1 divided by sine. It's okay. It takes a lot of practice. Well, look at our tools. You know, if you're sitting there on your homework tonight looking in your toolbox, well, you're going to have to look in your toolbox and see what you have. You may have a hammer, a screwdriver, and a wrench. That won't help you much in trig, but you have these. Which one of those three could we possibly use and do anything with that left-hand side? Yeah, there are no squares hanging around, which makes me think it's not this tool. It is a rational expression, so we could split it. I just don't know where we'd go after that if we split it. So I'm thinking I don't have any good ideas other than writing cotangent as cosine over sine and tangent as sine over cosine. I don't know where that will take me, but I just can't think of anything else to try. Miss Raven, do you have any ideas at that point? I'll tell you one thing I probably wouldn't do, something that occurred to me that I just went, eh. You could get a common denominator and add or subtract these two fractions, but if you did, you'd have a cosine square minus sine square, and cosine square minus sine square is not one of your trig identities. That's why I think no, because then you'd have negative sine square plus cosine square, and that's still not a trig identity. In order for factoring out a -1 to help, the sign of both terms would have to be changed. Chris, what was your idea? Mm-hmm. Not yet. Say it one more time. Well, are you talking about multiplying the whole fraction by something?
I guess.
Say it one more time and let me listen carefully.
Take cosine over sine.
Uh-huh.
And multiply by the sine, cosine.
And when you say the denominator, you're talking about this denominator. All right. If you do that, or the only way you can do that is if you do that to both the numerator and the denominator. You can't just do it to the top and not do it to the bottom also. And if you did it to the bottom, you'd have in parentheses sine plus cosine with the square outside.
Well, I think I'm thinking, property that allows you to, like when you have a fraction divided by a fraction,
Mm-hmm.
yeah, I guess you would flip it then.
Mm-hmm.
So then you would multiply it. I think if you put the denominator, like turn it into a fraction over
Mm-hmm.
1,
Mm-hmm.
then you can flip them and multiply them,
Okay.
which I didn't flip them, but I should.
All right. Let me write this down and see if I get what you're saying. Instead of divided by sine plus cosine, you're saying multiply by 1 over sine plus cosine. All right, that's legal, absolutely legal. And then you're wanting to distribute this.
Well, I was thinking you have stuff that cancels.
But see, you don't. That's the thing. When you multiply this times this, you can't cancel that cosine because that cosine's a term. So I had to write down what you were saying and then figure out if that was legal